this video helpful, please like, subscribe and press the bell icon for notifications. Today in complex numbers, we will be focusing on polar form of it. So as we know that in standard form or Cartesian form, the complex number represents a point AB on real and imaginary plane, and this point is the end point of a line starting from the origin that represents z is equals to a plus bi with magnitude mode of z. Now the polar representation of a complex number uses a radius r and an angle theta, where r is the radius and is equal to mode of z, where theta is the angle between the positive real axis and the line segment of z, and theta is positive for anti-clockwise direction and it is negative for the clockwise direction. Now let's convert standard form into polar form of complex number. So for that, let z is equals to a plus ib be any complex number. Then on complex plane with real and imaginary axes, point P r theta is the polar representation of complex number with r as a radius, and it is a unit to the right and b units up, and r is equal mode of z, and there is a theta angle between the positive real axis and the r. Now in right angled triangle PAO with theta between AO and OP, B can be written as r sine theta and A is equals to r cos theta. Then we just need to put the values of A and B in our standard form. So we will get z is equals to r cos theta for A plus I r sine theta for B. Take r common, so we will get cos theta plus I sine theta. So z is equals to r times cos theta plus I sine theta is the polar form of complex number z, where r is the radius and is equal to mode of z, and we know the value of mode of z is root of a square plus b square, and theta is also called argument of z and denoted by argz, and it is the angle between positive real axis and the line segment OP. And tan theta is equal b over a, so theta will be tan inverse b over a. So theta will be positive for anti-clockwise direction and it is negative for clockwise direction. Now let's go into detail about the theta part, and let z is equals to a plus bi be any complex number where a is positive and b is also positive. So this will fall in first quadrant. So the polar representation is a point r theta, where theta is the angle between the positive real axis and this line segment, and which is a unit to the right and b units up, and theta is positive because it is anti-clockwise direction, and tan theta is equals to b over a, so theta will be tan inverse b over a. So here theta is positive, so it will remain positive. Now for z is equals to minus a plus bi, here minus A is negative and B is positive, so it will fall in second quadrant. So PRQ will be in second quadrant. Now this line segment makes angle theta with positive real axis, because theta is always with positive real axis. So to find the value of theta, let this line segment makes angle alpha with negative real axis. Then we can find the value of alpha and subtract it from the 180 degree or pi to get theta. So theta will be 180 degree minus alpha. And the alpha will be tan inverse B over A, and we will subtract it from 180 degree to get theta, and theta will be positive here because it's in anti-clockwise direction. Now for z is equals to minus A minus BI. So as we can see, both are negative, so they will fall in third quadrant. So now this line segment can make angle with positive real axis in two different ways, one clockwise and one anti-clockwise. So which angle we will take? So anti-clockwise direction theta 1 is greater than pi, whereas clockwise direction theta 2 is less than pi, and we always take theta between minus pi and plus pi. So we will consider theta 2 here, not the theta 1, and to find the theta 2, let this line segment makes angle alpha with negative real axis. Then theta 2 will be pi minus alpha, where theta will be negative because of the clockwise direction, and alpha can be found out by alpha is equals to tan inverse B over A. Now let z is equals to A minus BI, where A is positive and B is negative, so it will fall in fourth quadrant. Now again this line segment can make angle theta with positive real axis in two different directions, one clockwise and one anti-clockwise. Anti-clockwise one is greater than 180 degree, whereas clockwise direction one is less than 180 degree. So we will consider less than 180 degree because argument of z falls between negative pi and positive pi. So theta will be tan inverse B over A, and it is negative because of clockwise direction. Now let's find out the polar form for z is equals to minus 1 plus I root 3. And we know that the polar form is equal r cos theta plus I sin theta, and r is mode of z, and mode of z is root of a square plus b square, where a is minus 1 and b is root 3 here. So we will get root of 1 plus 3, that is 4, which will give us 2. So r is equals to 2. And this complex number will fall in second quadrant because a is negative and b is positive here. And if this line segment makes angle theta with positive real axis and angle alpha with negative real axis, then theta will be pi minus alpha. Tan alpha is root 3 by 1, so alpha will be pi by 3. So if alpha is equals to pi by 3, then theta will be pi minus pi by 3, that is 2 pi by 3. So the argument of z is 2 pi by 3, which is positive because of the anti-clockwise direction. So we know the value of r and we know the value of theta. We just need to put these in polar form. So we will get 2 times cos 2 pi by 3 plus I sine 2 pi by 3. But there could be infinite number of polar equations for the same complex number. Let's find out how. Now if this line segment makes an angle theta with the positive real axis, then if we take one full circle and then reach to this line segment again, then we will be making 360-degree plus theta angle. So our theta will be theta plus 2 pi. Again, if we take second round and we come back to that line segment again, so this time we will be making theta plus 2 pi plus 2 pi because we took 2 round. So it will be theta plus 2 times 2 pi. So where theta is the argument of z and 2 times 2 pi can be written as n 2 pi, where n represents the number of circles we are taking. So we can say that theta is equal argument of z plus 2 pi n, where n is 0, plus minus 1, plus minus 2, plus minus 3 and so on. If argument of z is 2 pi by 3, then complex number z is equals to 2 times cos 2 pi by 3 plus I sine 2 pi by 3 is same as z is equal to 2 times cos 2 pi by 3 plus 2 pi for n is equals to 1 plus I sine 2 pi by 3 plus 2 pi, or z is equals to 2 times cos of 2 pi by 3 plus 4 pi plus I sine 2 pi by 3 plus 4 pi. We will get the same complex number, or we will touch the same line segment. Therefore, we will get the infinite number of polar equations. Now let's take an example and write the polar form for 1 minus I. So we know that z is equals to r cos theta plus I sin theta is the polar form of complex number, and r is equals to mod of z, which is root of a square plus b square. So we will get root 2 here. Here a is positive and b is negative, so it will fall in fourth quadrant and makes an angle of minus theta because of the clockwise direction. So tan theta will be 1, so theta will be pi by 4, but theta is negative, so it will be minus pi by 4. So r is equals to root 2 and theta is equals to minus pi by 4. So the polar form of 1 minus I will be root 2 times cos minus pi by 4 plus I sine minus pi by 4. But there could be infinite number of polar equation for the same complex number 1 minus I. So if we add 2 pi to the theta, then we will get the same complex number, or we will reach to the same line segment. Similarly, if we add 4 pi to the theta, again we will reach to the same line segment, or we will get the same complex number. So we can go on and on to get infinite number of polar equations, because our theta is equal to argument of z plus 2 pi n, and the value of all the thetas will be equal. Exponential form of complex number is our next topic. Thanks for watching.